Now, here we saw last time that Dalton's theory had some limitations. Now, experiments were going on to find out, that is, what were the other particles, subatomic particles present in an atom. That was, Thomson studied about the structure of atom by performing some experiments on the cathode ray tube, and he proved that there were particles which were called electrons. Let us see how he proposed this atomic model and how he came to this conclusion. In Thomson's atomic model, there was a mass of positive charge in which the negatively charged electrons were embedded like the plums in a pudding. So this model was also called as plum pudding model. But how did he come to this conclusion? He studied the observations from cathode ray tube experiments, and he concluded that all matter consisted of negatively charged particles. These negatively charged particles were present inside the atom. Till then, they were described as the tiniest particles of an element. The atoms were described as the tiniest particles. He proved conclusively that atom is divisible, and he proposed that an atom consists of a mass of positive charge in which remains embedded the small negatively charged particles, and that time he called these negatively charged particles as corpuscles. He suggested that this model of atom appears to be like a plum pudding model of atom. So, because the plums were embedded in the pudding, like the negative charges are embedded in the positive charge mass. Why did he think of this? He said, if an atom has to be electrically neutral, then the total positive charge must be equal to the total negative charge. But then the question still remains, how did he conclude that there existed negative charges in the atom? It was a cathode ray experiment which led Thomson to discover the electrons. Thomson used Crookes tube to understand the emission of cathode rays. Crookes tube appeared to be like this, as a simple glass tube with two electrodes at the opposite ends. The tube is sealed at both ends and it is connected to a vacuum pump from one side. The electrodes were such that they could be connected to a high voltage battery. So here you see the structure of Crookes tube. This is the simplest structure, the glass tube elongated. This is the electrode on one side, the cathode, this is the anode. They both are connected to a high voltage generator. Inside the tube there is vacuum, and that has been done by connecting the tube to a vacuum pump. Vacuum, that implies air at a very low pressure. Now, what happened when the voltage was generated? The negative rays were originating from the cathode and they were striking on the opposite side of the cathode on the glass tube. They were causing the glass tube to glow wherever they struck the glass tube. That is, we say the screen fluoresced when something struck it. What was it? Why did the negative rays do such a fluorescence on the glass tube? Now these moving rays, because they originated from the cathode, were called as cathode rays. And you know, the cathode ray tubes were used in the old model of our television sets. The observations which Thomson made from the cathode ray tube experiment was that the cathode rays, when they strike the glass, they cause the glass to glow. Second, when any object is placed on the path of the cathode ray, then the cathode rays cast a shadow of that object. That means cathode rays travel in straight lines and they can cast a shadow of any object placed on their path. Further, these rays could be deflected in presence of an externally applied magnetic field. You see the magnetic field, it is applied in this figure over here on top. P1 and P2 are the externally applied electrodes. I should say the field is applied between the two plates of P1 and P2, and we can see the cathode ray deviating from its original straight length path to something towards P2. Now, in the next observation, Thomson saw that these rays could also be deflected in presence of an externally applied magnetic field. So, when he surrounded this cathode ray tube externally by a magnet, then he saw that the rays which are originating from the cathode started getting deflected. So, he concluded that the cathode rays are deflected by externally applied electric field as well as by the externally applied magnetic field. And after deflection, when they struck the glass screen, again they fluoresced.